Hi everyone. Today we are going to start a new topic under A2 Unit 3. That's topic 16 titled as Emerging Technologies. It's impossible to predict the impact of these emerging new technologies on individuals, the organizations, and also on the society. So, in this unit, you will understand the three main emerging technologies. First one on machine learning, and in the second next lesson on the technology of virtual and augmented reality, and the last and the third emerging technology in the spec, the Edexcel spec is IoT, Internet of Things. You need to know their implementation and their impact on the individuals, organizations, and the society under the A2 syllabus. So, if the time permits, we will see some model questions too. So, watch the video and don't forget to subscribe and click on the bell icon to get the notification when I upload a new lesson. I got this screen capture from the latest Edexcel A-level IT subject specification. Under topic 16, you have three main subtopics. Those are, as I mentioned earlier, machine learning. The second one is VR and AR, and the third one is on IoT. So this spec shows what Edexcel is expecting us to learn under these emerging technologies. Don't worry that it's in tiny font and not easily readable. You either can go to the spec and read on yourself. If not, don't worry. We are going to cover all these in our lessons. So, machine learning in association with big data has the potential to change the way we live and work. And the second topic, virtual and augmented realities, like already play a part in our entertainment and safety assurance. The Internet of Things, is as more and more devices connect online, there's a huge impact on our daily lives. We will discuss this in detail in the lessons. Okay, so let's focus on today's lesson, that is topic 16. Under topic 16, which is emerging technologies, we have 16.1, that is machine learning. So the focus today is on 16.1 machine learning. Basically, we need to know what is machine learning, features of machine learning, the two main machine learning types, that is supervised and unsupervised learning, and we are going to compare the two learning methods, and then we need to see the impact of machine learning and its possibilities to the individuals, organizations, and to the society. So, machine learning is a branch of artificial intelligence and computer science, and it focuses on the use of data and algorithms to learn the way that humans learn, and by gradually also improving its accuracy. You give set of training data and it goes through an algorithm and it can learn continuously, and then the model get trained, and then with that data and the algorithms and the way it has trained, it can give the results. So examples of machine learning are like it is used in chatbots, digital assistants, and when we are, you have seen in the email, some goes to the spam. So implementing spam filters, and when we are typing a word, it shows the possible words, that is autocomplete, that is also machine learning. And then face tagging, when you're uploading a photo to social media, it shows the faces and it allows you to tag those people, so that is also machine learning. And also in self-driving vehicles, so there are so many things in traffic management, in natural language processing, in financial trading systems, and when stock prediction, stock price prediction. So so and so and so, it's all over the place, though we don't realize it in our lives that it's machine learning. So let's go through this. So let's see why machine learning has become so important. The demand for machine learning is steadily rising because it's able to perform tasks that are too complex for a person to directly implement. Machine learning is required to do complex tasks, and also the tasks that are where there's so much of data. Uh, so humans are constrained by our inability to manually access vast amount of data. So as a result, we require computer systems which is where machine learning comes in to simplify our lives. So, as mentioned before, also the primary reason machine learning is so important, it is ability to handle and make sense of large volumes of data with the like, explosion of these digital data from social media, Facebook, Instagram, and so Twitter, and so on, so on. Sensors and also the sources of traditional data analysis methods have become like inadequate. So it has found that, for an example, if I take one data, it has found that over 1 billion stories, Facebook stories, get posted every day across Facebook apps only. So that is only just one social media app. There are so many. So imagine the amount of the data that is added on daily basis. So machine learning is driving innovation and efficiency across various sectors. Like few examples are in healthcare. Machine learning algorithms are used to predict disease outbreaks, to provide personalized patient treatment plans, and to improve the medical imaging accuracy. And in finance, also, machine learning is used for stock market trading predictions, decision makings, and also in fraud detections as well. And in retail industry, recommendation systems, when you buy from amazon.com, and when you're searching for products, it shows you some recommendations, right? So it gives those recommendations based on the previous data that the amazon has under your profile. So it stores that data, and that data is used to give the recommendations, personalized recommendation products for you. And another importance is machine learning is a key enabler of automation. By learning from data and improving over time, machine learning algorithms can perform previously manual tasks, so it can free the humans to focus on more complex and creative tasks. So this is not only increases the efficiency but also opens up new possibilities for innovation. So machine learning is important because it has this huge data processing ability, and it helps us to do a lot of innovation, and also it helps us automate the task. Okay, machine learning has these features of predictive modeling, automation, adaptiveness, scalability, and generalization, and so on. So on. There are a lot, right? So in predictive, the these are the features. So in predictive modeling feature, data is used by machine learning algorithms to create models that forecast future events. For an example, predicting risk of a loan. So let's we can feed someone is going to take a loan, whether that giving that loan has a risk. So those predictions can be made through machine learning. And also predicting likelihood of a customer buying another item along with something else. And also another feature is automation. Machine learning algorithms automate the process of finding patterns in data, like requiring less human involvement. And then scalability, machine learning techniques are well suited for processing big data because they are made to handle massive amounts of data. And then generalization, algorithms for machine learning are capable of discovering broad patterns in data that can be used to analyze fresh and unexplored data. And then adaptiveness, as new data becomes available, machine learning algorithms are built to learn and adapt continuously, keep on learning. As a result, they can enhance their performance over time, and it can become more precise and it can become more efficient. So it gives more benefits to the humans. Okay, so there are two main fundamental types of machine learning. Uh, Under your syllabus, we are learning only two, supervised learning and unsupervised learning. There are some other called reinforcement learning and so on, but in your syllabus, it's enough to know about supervised learning and unsupervised learning. So, as part of machine learning software development, we need to train or teach the software how to identify inputs and generate accurate outputs. There are the two main types, as I mentioned, supervised learning and unsupervised learning. And supervised learning refers to the type where the machine learning is trained, similar to a teacher supervising and teaching what is correct and what is not. So to do so, we rely on input to output mappings. Bigger the data set, the more accurate outcome we can get. And in the second type, this unsupervised learning, here we don't rely on input to output mappings. This strategy has become even more autonomous and efficient in discovering the underlying structures of the unlabeled data. So, uh, and we need to see the differences between these two. The biggest difference between supervised and unsupervised machine learning is the type of data used. Supervised learning uses labeled training data. It sort of, let's say, we are giving training on vegetables, and it labels these are carrot, these are cabbage, and likewise. Um, but unsupervised learning does not label the data. It has a mix of data. So therefore, supervised learning is less complex and easy to understand, while unsupervised learning is complex and there's data ambiguity as well. Supervised learning uses input and output data mappings, but unsupervised gives only the input data. It doesn't give a mapping of output. And then supervised learning takes place offline and unsupervised takes place online. Supervised learning is used in sentiment analysis, price predictions, weather forecasting, and spam detections. Unsupervised learning is used in medical imaging, also in e-commerce sites, recommendations engines. Here are a few examples of machine learning. Yes, machine learning is used to show the recommended products for customers based on their previous buying patterns, bought products. So, yeah, have you thought of how Google Maps shows different routes to you, like when you are searching on a map, when you need to go from one place to another? Uh, have you ever thought of like how Google Maps show these different routes to you depending on the time that you're searching or the traffic status or the type of vehicle that you're going in, etc. So because it uses machine learning algorithms to show you the routes, you can read on how this is happening from the back end in the internet, and Google it and see it's interesting. Likewise, in this screen and in the next screen also, I have listed many examples of machine learning. Please pause the video and read through and Google if you're interested to know how they work, because it's beneficial for you to know these, because in case if the exam paper gives you a scenario question and ask how AI or even machine learning or even emerging technologies can enhance the service, so knowing these practical examples will help you to answer your question. Okay, these are the next set of machine learning examples. Please go through and read them. Yeah, from this slide onwards, there are four slides that we are learning on the impact of machine learning in four areas, mainly on machine learning in natural language processing, machine learning in speech recognition, machine learning in image recognition, and machine learning in pattern recognition. So, hope you have heard the word natural language processing, shortened as NLP. It has a literal meaning. Natural language processing is a branch of artificial intelligence. NLP basically enables computers to comprehend, generate, and manipulate human language. Uh, so natural language processing helps computers communicate with humans in their own language. For example, NLP makes it possible for computers to read text, hear the speech, interpret it, measure sentiment, and determine which parts are important. So, NLP is used because of these possibilities. NLP is used in chatbots. Uh, Natural language processing chatbot is a software program that can understand, respond to human speech we ask a question, and then they process what we are speaking into text, and then they interpret it in an answer. So that's how the chatbots work. Uh, that chatbot program is trained that they can understand and respond to human speech. So these chatbots are powered by natural language processing. It allows people to communicate with computers in a way that it feels natural and human like. You don't feel like you are talking to a computer, but you feel like you are talking to a person behind. Like Apple Siri and Amazon Alexa, right? So Apple Siri and Amazon Alexa examples of consumer-oriented, data-driven, predictive chatbots. That's why I mentioned sometimes we are using these features without knowing that the underlying technology is machine learning, right? Okay, machine learning in speech recognition. Speech recognition or speech to text is the ability of a machine or a program to identify words spoken aloud and convert them into readable text. Virtual assistants like Siri or Alexa, they use a speech recognition system to process the audio, transcribe it into text, and then pass it to the natural language processing system. So, machine language algorithms play a crucial role in making the recognition process of accurate and effective. Speech recognition and voice recognition, are they the same or are they different? Please note that speech recognition and voice recognition are two different technologies and should not be confused. So, speech recognition is used to identify words in spoken language, whereas voice recognition is a biometric technology for identifying a person. You have seen some devices or door locks that functions based on the voice of your voice, so that is voice recognition and not speech recognition, right? The third one is machine learning in image recognition. Image recognition allows machines to identify the objects, the people, entities, and other like variables in an image. Please see the image on the screen so you can figure out. The image recognition allows you to identify the objects like the car, and also sometimes the number plate. So, major applications include object recognition, medical diagnosis, image search. When you are searching in Google, you can search with image search, right? And also in self driving cars. Image recognition also used in face recognition. So it this is a common application of image classification. Like face recognition can be used to identify people in images or even in videos. So this technology is used in a variety of applications such as security applications and also in social media. As I mentioned before, so in Facebook, when you upload a video or a photograph, it captures the face using image recognition, and it allows you to tag the people in each face. So that's how when you upload a photo, yeah, that is how it is working, right? And also in vehicle recognition, it's using image recognition. uh, it can distinguish between a different types of vehicle, whether it's a car or a truck or a bicycle or motorcycle. So this is useful in traffic surveillances and also in transportation, and heavily can be used in parking management. Right. And also, image recognition is used in disease diagnosis in medical images. AI models can be trained to detect signs of diseases such as tumors or even bone fractures or abnormalities in the x rays. And in MRI scans and CT scans, they can diagnose the diseases that's displayed in these images. So this helps radiologists and also in the healthcare professionals in making accurate diagnosis. And also, image recognition is used in satellite images. Image classification is used for analyzing satellite and aerial images, enabling tasks like geography classification, and also in disaster monitoring, and also in urban planning. Those images can be used in those tasks. And also in wildlife identification, image classification can be used in wildlife conservation to identify and track various endangered animals, so helping researchers to monitor and uh, do their work. Right. And the fourth is machine learning in pattern recognition. Right. Okay. For humans, pattern recognition is a cognitive process, right? In the brain, we can identify, like, we don't have to think about it, or effortlessly we see with the data stored in our memories, and we can instantly differentiate between an image of a flower from an animal, right? And also we can identify familiar face when we are scrolling our Instagram page or Facebook pages. But have you ever wondered how new technologies like Alexa or even Google image search work? uh, because they don't have a brain, right? And they don't have previous data. So pattern recognition helps to solve classification scenarios like biometric detection problems, and in the hospitals, classification of nodules into tumorous or non-tumorous cells. In medical imaging done with the MRI scans, it can detect the pattern and see whether it's a abnormal pattern, and whether there's a tumor or anything unsuspicious thing is there. And when we are doing image search using Google, it takes input as an image, and then it check the pattern of that image, and then it matches with that pattern to give the image search results. So while we see so many benefits, there are some pattern recognition challenges as well. So in your exam paper, they might give you a scenario where machine learning is applicable, and then they might also ask what are the practical challenges you face when implementing machine learning. So let's see some common challenges. Pattern recognition tends to be like data hungry, because in other words, it needs much training data to require to train for that pattern analysis, otherwise it can't give the prediction or the results. So you need to have so much of training data to get the correct results. And also when the data is not in good quality, when the data is ambiguity, and when the data is having noise and not clear, the success is very low. So the data that we are going to train the machine learning algorithm should come from reliable sources. It should be free from bias and noise. And another challenge is it takes long training time, because you have to use so much of data, vast amount of data, and you need to train it for a long time. I mean, you need to collect data, and then you need to pre-process it and remove the noise and corrupted data, and then you need to train the model, train the algorithms, go through the algorithms and train the machine learning process. So it takes long training time. That's also a challenge. Right. Okay, so far we discussed the four things mentioned in the Edexcel spec as well: machine learning in natural language processing, machine learning in speech recognition, machine learning in image recognition, and the last one, machine learning in pattern recognition. These are a couple of useful sites if you are interested to dive into, in mainly if you are planning to do your degree in computer science or information technology. Uh, going through these sites will help you, and yeah, these two resources are provided by in the Pearson teacher resources as well. So if you have free time, try to go through this. And yeah, Let's see a couple of questions and answers as well. The question is, what are the applications of supervised machine learning in modern business? Yeah. Yeah. It says here you reading the question and answer by yourself, so I'm not going to just read the answer in the slide. Take your time and read. And if you are having issues, either put a comment in the lesson or you can yourself Google it and see as well. Question 2: how is Amazon able to recommend other things to buy when you make a purchase? So when you buy something from Amazon, Amazon stores that purchase data, right, for future references, and then it helps to find products that are most likely also to be bought together. So it's possible because the algorithm stores your previous buying patterns, buying products, and all that, and it can identify patterns using machine learning and suggest the user what else to buy. I have underlined the words that should be in your answer so that you can get a feel of it. Right, I think we are done. Yes. Okay, so that's it for machine learning, and stay tuned for the second lesson on emerging technologies topic, that is on VR and AR, virtual reality and augmented reality. So don't forget to subscribe, guys. See you in the next lesson, that is on VR and AR, and after that it will be IoT, Internet of Things. Okay, have a nice day and good luck.